زيادة حجم.
Morning, ladies and gentlemen. How's everybody doing today? Doing good? My name is AhmedFayaa and I am a third-year medical student. This is a day I've been looking forward to for quite some time now. I've been looking forward to introduce you to one technology that is so sophisticated, promising, recombinant DNA technology. Before we get started, I would like to point out that this certain topic is way over my educational level. I have dedicated a lot of time and effort in collecting these information. Hopefully, still be doing something. Again, I'm very fascinated by such topics because when medicine and technology are used together, biotechnology, ladies and gentlemen, opens up a whole new door for treatment and prevention of disease. It does, and we're about to see how. We'll start off by discussing, understanding, introducing the idea behind recombinant DNA. And we'll see some applications that may have an impact on this technology. Recombinant DNA, in fact, is an artificial DNA that is formed by combining different strands of DNA from different organisms. So you're taking a piece of DNA from one organism and you combine it with the DNA from another organism. This creates a new sequence that would not otherwise be found in biological organisms. To further clarify how this works, we'll take a gene from our own DNA, a gene that encodes for insulin production. Let's say insulin production. A gene that encodes for insulin production. And we'll insert this gene into a plasmid. This is a plasmid. As you may know, plasmids are nothing but a small circular DNA molecules found in bacteria like Escherichia coli, for example. As you know, plasmids grow independently. Plasmids are not essential for the bacterial growth. And I personally think this is one of the reasons why they're used as vectors. They're used as vehicles to transport foreign genetic material. So taking the desired gene, in our case a gene for insulin production, inserting this gene into a plasmid, transferring this plasmid into a fresh bacteria host, eventually this will create a bacterium that produces insulin. And don't make this start on how useful that is. This is very useful. We'll see why in a minute. But the thing is, the point that needs to be noted, if you don't know already, is that this theory is possible. Because all organisms share the same chemical structure of DNA. They only differ in the sequence of nucleotides. Otherwise, they're completely identical, and this is possible. Alright, let's have a look at this. This is not a mouse, for those of you who are wondering and laughing. This is not a mouse. This is definitely a mouse. It is called a chimera. And modified organism, and genetically modified organism happens to be called a chimera. If you look closely, one eye is red, the other is black. It would be a chimeric mouse. so extreme. Now don't get me wrong, I don't prove this. As a matter of fact, in this life, I just look this picture to show you what this technology is capable of. At the end of the day, we want to cure diseases to create a more environment. So yeah, don't mind this much information. This is important, and a lot of attention. This is important. No? In case you haven't figured out this by now, there's a wide range of applications for this technology. One application is human recombinant enzyme, aka human. This was the first drug generated by rDNA. Leave that aside for a moment, just leave it aside for a moment, and let's just talk about the history of the human enzyme so you can appreciate the difference. In 1922, animal insulin was used for the treatment of diabetes. Unfortunately, it has consequences. One of which was allergy. It couldn't be used for diabetic individuals who are allergic to insulin preparations from cows, porks, animals in general. Not only allergic individuals, but even non-allergic ones. You see, animal insulin and its structure, it's different from human insulin, obviously. Using animal insulin as a treatment for diabetic individuals may result in some sort of a stimulation in the immune system. Because it will recognize this type of insulin as a foreign body, producing antibodies against it and causing hypersensitivity. Back in the 20s, when animal insulin was used, the rate of hypersensitivity was high. It was really high. Now that you have human insulin obtained from animal sources is no longer used, no longer produced, no longer needed. Oh, it's effective. Do not misunderstand me. Animal insulin is effective. Yes, it decreases blood glucose level, goes to the lovely, but it has its adverse effects. Unlike human, which is perfectly fine with medicine for diabetic individuals. The discovery of human gave rise to the birth of, are you getting bored? Are you okay? The discovery of human gave rise to the birth of recombinant DNA era, and really the birth of biotechnology.
They are the second class, yes. I prefer the second ones.
It was the beginning of revolution discovering
so that they don't see any
Since we're discussing insulin preparations and disease like diabetes, we all know we can't prevent diabetes, we can't prevent such disease. Experts are going on to develop a novel approaches to prevention. One approach is focusing on replacing the beta cell that have been destroyed with a new source of beta cells. The alternative approach is the concept of regenerating endogenous beta cells in someone who has diabetes type 1. The other exciting approach, very exciting approach, some biotechnology companies are pursuing, is the concept of converting another cell in the body to become a beta cell. But still, these are our expectations. Beta cell transplantation is it's not yet successful. Scientists are facing a number of difficulties. You see, it is difficult to remove the beta cells from the nucleus. It is even more difficult to keep these beta cells from being attacked by the immune system of the host. Some technologies are being developed to overcome this. Just to get this over with. The reason that kept me digging even more and more into diabetes, although it's not my topic today, but the fact that my own father, uncles, aunts, cousins, and even few friends, they all have diabetes. I am surrounded by people who suffer from that disease. And I'm sure most of you find audience know at least a person or two who does. Whenever we talk about a disease like diabetes, whenever we do, we're talking about a disease of the generation, really a disease that conquered the world. It did. We know for a fact that it did.
It's something that you...
346 million people worldwide have diabetes. Do you know how much that is? That's more than the population of a country like the United States. I did the math. That is 5% of the world population. Unthinkable.
Yeah.
And while doing my research, I came across this doctor, Dr. Richard Ansel, who believes that a vaccine for diabetes will be discovered. He predicted could be in mid-20th century.
I never used it.
And that happened. It will be the beginning of a revolution, one that will change the life of millions. Let's just list some other applications regarding rDNA, such as prevention of cystic fibrosis, as well as sickle cell anemia. And if you just think about it, just take a moment and think about it. Unlike most conventional medicines, and instead of treating the symptoms of a disease, recombinant DNA or gene therapy has the potential to correct the underlying cause. Therefore, it is a very, very promising future in the field of medicine, ladies and gentlemen. Oh yes, this is my personal favorite part. Here's a fact. I didn't know about the concept of combining different DNA. Recombinant DNA, I didn't know about it. This movie was such an inspiration for me. I remember watching it with my younger brothers. It really got me thinking when they introduced something called